Okay, till now we have learned pre-order traversal, in-order traversal, and post-order traversal, and we have created these functions using Java programming language. Now here we will look at the last type of the traversal in case of binary tree, which is level order traversal. As the name implies, in case of level order traversal, we traverse tree level by tree. It means that first we are visiting first level, then we are visiting second level, then we are visiting third level, and then we are visiting fourth level in this case. But it depends on the number of the levels in a binary tree. So how many levels we have, we are going to continue to till last level. So in this case, in our binary tree over here, in the first level we have only one node, which is root node, and in the second level we have two nodes, and in the third level we have three nodes, and in the fourth level we have two nodes. So here, when we are starting traversal using level order traversal, the first node that we are going to visit is N1, which is root node. Now after finishing the first node, we are going to continue to the second level. So in the second level, we are always going to start from the left subtree. So we are going to visit the N2 in this case. Then we are going to continue to the N3, which is right subtree. Then after finishing second level, we are going to continue to the third level. So in the third level, the leftest subtree is N4. So we are going to visit N4. Then we are going to continue to the right subtree, which is N5. Then we are going to continue to the left child of right subtree over here, which is N6. Then we will continue N7 in this case, which is right subtree of right subtree over here. And after finishing level 3, we are going to continue to the level 4. So in the level 4, we have two nodes, so which means that we are going to start to loop through the N8 and N9 in this case. So with this, we have successfully implemented level order. So based on this logic over here, the order of visit in case of level order will be like this. First we are visiting root node, then the second level, then we are continuing to the third level, so we are visiting all nodes of the third level, then we are continuing to do the fourth level, so we are visiting all nodes of fourth level in this case. So in this case, as you can see, the order starts with first level, then it continues to second level, then it continues on the third level. So whenever we are going to the new level, as you can see, from the right part we are coming to the leftest part, so we are starting always with the left node in this case. So with this, we have successfully visited all nodes of this binary tree over here using level order traversal. Now based on this logic, we are going to create a method in practice to see how this is working. So in this case, we are going to use QDataStructure to take the order of nodes from the levels over here. Now let's head over to Java. So here inside binary tree class, we are going to implement our level order traversal over here. Now before implementing it, we need to import some data structures over here, because as we mentioned, this binary tree works based on the linked list. So the first data structure that I'm going to import is linked list, and the second one will be queues, because we are going to create level order traversal based on queue class over here. So the thing is, we are going to start from the root node and take all nodes and insert them to the queue, and then we are going to dequeue them one by one, because in queue the first node that comes in comes first out. So this means that this will give us the order of levels in this case. So I'm going to declare our method like this. So it's going to be the name of the level order traversal. So I'm going to name it level order. So this method will not take any parameter. So here the first thing that we are going to do, we are going to create a queue. So I'm going to create queue based on the binary node. So the type of queue will be binary node, because we are going to insert the nodes of this tree over here. So that's why I'm going to create as a type of binary node. So the name of queue will be queue, and I'm going to create based on the linked list. So it's going to be like this. Linked list will act as a queue over here, and the queue class that we have imported will be the interface in this case. So here it's going to be type of binary node. Now after creating this queue over here, the first thing that we are going to do, we are going to take the root of this binary tree over here that we created. We are going to insert this root as a first element of this queue over here. So this means that I'm going to call queue.add. So this will add as a first element the root over here with root. Now after adding this, we are going to check that while this queue is not empty, we are going to take the elements from this queue one by one out, and we are going to insert the elements which are located first in the left subtree, then the right subtree. So I'm going to write loop like this. While queue is not empty, so I'm going to call is empty method. So in front of this, if I put exclamation mark, it's going to be not empty. Then we are going to do it like this. The first thing that I'm going to do, I'm going to create a node in which we will save the value of the first node in this queue over here. So it's going to be like this. Binary node is equal to binary node present node. So I'm going to name it present node. So this will take the value of queue.remove. So if I call remove function, in this case, it's going to return the first element from the queue, and it's going to remove that element from the queue in this case. Now, after doing so, we are going to print out the value of this present node over here. So in this case, it's going to be like system out print, then in this case, it's going to be present value. Then to make our output readable, I'm just going to add an extra space after this node value over here. So after doing so, as we mentioned before, we are always starting from the left children, because as we said, in case of level order traversal, we are visiting from left to right. So in this case, I'm going to put, if we have left child in the present node, so if present node dot left is not null, in this case, we are going to take this element and add it to this queue over here. So it's going to be like this, queue dot add and present dot left. Now with this, we are adding the left subtree node to this queue that we created over here. Now after doing so, we are going to do the same operation for the right subtree. So I'm just going to copy this code from here and put it over here and change it to right. Now after doing so, first left subtree node will come out, then the right subtree node will come out. So we will have order of from left to right. So with this, we have successfully implemented our level order in this case. Now let's see how this is working in practice. So here we have created our binary tree. So this is the binary tree that's like with this picture over here. So in this picture, we have shown the order of the nodes that we are going to visit in case of level order traversal. So if I call level order traversal after creation of this binary tree, the order should be the same as that is shown in this picture over here. So if I run our code, now in this case, it's returning the nodes every time in new line. So here inside this level order class, if I change it from println to print and rerun our code, in this case, you'll see that it's going to print out in one line over here. So as you see, the order in case of level order traversal is like this. So first we are visiting root node, which is N1. Then we are continuing to the left child, which is N2, which is located in the second level. Then N3. Then we are continuing to the third level, which is N4, N5, N6, and N7. Then in the fourth level, we have N8 and N9. So we are visiting in this order. So as you can see, the order of elements in this case is similar as the order that is shown in this picture over here. So with this, we have successfully implemented our level order traversal. Now let's see what's the time and space complexity for this method over here. Now as always, we are going to start from the first line of this method. So in the first line, we are creating a queue using linked list class. So this line of code will take O1 time complexity. Then we are inserting a root node to this queue over here. So this one also will take O1 time complexity. Then we are looping through all elements of the linked list. While queue is not empty, we are enqueuing the elements to this queue and we are removing the first element from this queue over here. So this means that we are going to do this operation for all nodes. This means that it will take O(n) time complexity. Then we are removing the first element from the queue. So this one will take O1 time complexity. Then we are printing out the value of present node to the console. So this one also will take O1 time complexity. Then in the if condition, we are checking that if the left of this tree is not null, in this case, we are adding the left tree to this queue. So this if condition also will take O1 time complexity. So then we are implementing same logic for right subtree. So this one also will take O1 time complexity. Now if we combine all these complexities over here, we get O(n) time complexity. Now the space complexity is also O(n) because in this case, we are creating a queue over here and we are enqueuing all elements of this binary tree to this queue over here. So this means that we have to allocate a space in the memory based on the number of elements in the binary tree. So this means that it will take O(n) space complexity. Now with this, we have come to the end of this lecture. So in this lecture, we have discussed the logic behind the level order traversal and we have implemented it in practice. And we have learned that the time and space complexity for this method is O(n). So hopefully everything is clear about level order traversal in case of binary tree. So see you in the next lecture.